Okay, hi. My name is Igor, and I'm gonna present you zero-cost speech recognition task this year on Mediaeval. As you noticed, it's a zero cost, and the story behind this task is that actually it's quite difficult to small or mid-size labs or even companies to build a new speech recognizer or ASR for a new language, because for that usually you need to buy a costly database. It can cost tens of thousands of euros to build ASR, and the price is in that you have audio and you need to have this audio really nicely transcribed, and this is why it's so costly. But actually there is lots of data outside these days, and this was the main motivation to use this data, which are somehow publicly available. There is full of internet of this data, and to use this data for training of speech recognizer. So that's why zero cost. The good thing is that you have data for free. The bad thing or the difficult thing is that this data is very noisy, right? Because you download lots of data from different resources which are heterogeneous. If you download audio with some transcript, the transcript can be erroneous, words are missing, or the transcript is in a different language. Audio can have some dropouts or can be even missing. So the participants have to cope with really noisy data, and this is what is difficult. This year we selected Vietnamese as a target language. The reason was that Vietnamese is not so spread language like, for example, English. So participants, there will not be some unfair advantage of some participants having good knowledge of Vietnamese. And also, the difficult thing of Vietnamese is that it's tonal language, but the easy point of view is that it's syllabic language. So you participants can aim at acoustics and do not need to really heavily download or research in making language models for opposite to, for example, some inflectional languages. Yeah, so it was kind of trade-off. There were two subtasks for zero cost. One was full ASR, which means participants were provided with evaluation data, audio, and they had to return transcripts, word or syllabic transcript. We scored that using standard word error rate metric. And the second task, kind of a little bit easier, is a tokenizer subtask, which means that the participants have to upload or have to provide a tokenization of audio, meaning then the tokens have to reflect the acoustics of the audio, the speech, meaning that tokens can be whatever, like graphemes, phonemes, xenons, triphones, automatically derived units, whatever, which somehow consistently reflects the speech. Here the scoring is a little bit tricky, so we aligned these tokenizations to reference phoneme alignment and calculated normalized mutual information, which means that we calculate how consistently the tokens reflects the phonemes. As this is zero cost, participants were encouraged to find and share more data. There was only limitation that the data had to be free for public, for scientific and public use. So they can download whatever they found. They can even use English, whatever other languages. There was no limitation, but it just had to be free. We also set up online scoring leaderboard. You can find it at zerocost.org URL, and participants uploaded output of their system. They were scored, show they had saw their results and compared to other participants. We also helped them with some starting points. So the co-organizer Xavier Anguera prepared a baseline system based on Caldi and Lifelong GMM, so participants can evolve and can start from that. Also to have it easier for them, we downloaded about 12 hours of data. So we find out about 3 resources. The first one, ELSA, it's a kind of proprietary system provided, proprietary data provided by Xavier for this task, and should be publicly available, I hope. And it's a set of about dozen speakers, few dozen of speakers reading several sentences. They were recorded on mobile phones in various I think public places. Next site we downloaded data from was forvo.com, which is a website for language learning, where you have lots of languages there. For each language you can find pronunciation of words, and if you don't found what you are searching for, so you can enter a word, and some native speaker will record this word, how it's pronounced, and you can learn language like that. RhinoSpike is similar to Forvo, but it's about sentences or even paragraphs. So you can, for example, paste there a paragraph in a particular language, and native speaker will read it, record in the website. So you have there lots of these audios with the text. And YouTube we used as part of the evaluation set, as an unseen channel, where we downloaded a few news and presentation and talks, all with the single speaker. It's kind of reverberant speech, and use this for evaluation. Altogether, it's about 20 hours for training, and I think it's about 2 or 3 hours for evaluation. Participants were encouraged to find and share more data, which happened. NNI, for example, provided some Vietnamese web pages, Wikipedia text, word list. BUT provided subtitles and some audio and video and subtitles for telenovels. So we put all of this data on one pile, and about 1 month before the deadline it was frozen, fixed, to somehow overcome a race of downloading more and more data, and to push the participants to focus on the research, not just downloading the data. We end up finally only with 3 participants. It's finished. It's kind of pity. The NNI participant who kind of won this submitted a fusion of 3 subsystems, all based on DNNs, and they used also data augmentation and used the data provided by other participants. They also used a fusion of several subsystems based on SGMMs and RNN language model, and also used the data augmentation and BUT as an organizer team we submitted a single system based on bidirectional long short-term memory neural networks. These three guides were for the ASR subtask. For the subword subtask, only BUT submitted a system which was based on automatically derived units, which means that it's also kind of a zero resource, right? Because in training of this system, there were no transcription used, just the audio. Here are the results. So this most right column is the test set. This is how participants see the results in the online leaderboard. And well, the last line is the provided Kaldi baseline for the participants trained on PLPs and GMMs. This yellow one or orange one, the late submission, this is a kind of baseline system for Vietnamese, which was submitted for NIST Open KWS or IARPA Babel, who is familiar with this program in US in 2014. So this is the beauty system which was part of the Fusion winning that evaluation. So we submitted this system or put it there to let participants frame with the state of the art, right? Because there was, for this evaluation, open KWS evaluations, there were lots of publications, so participants here can easily compare with state of the art. You can see that for the zero cost data, they achieved, all the system achieved better results than this baseline because they were adapted, they were well trained on this ELSA for Volino-SPAC data. On the YouTube, you can see here that the baseline is more robust, so it's better, but it's not so big difference. So I think that all the participants did very good job and trained state-of-the-art systems. Yeah. For the support, just quick note, again, comparison to baseline PLP GMM system, providing graphemes as the tokens. And you can see that the automatically derived units here are a bit better, so the system is also quite good because there were no transcription used, just the audio. To conclude, I would like to thank very much to all participants for their job. They did really well. Also for downloading and providing more data and using the state-of-the-art techniques. And well, I'm looking forward for the future. Anyway, the leaderboard and the data will be publicly available, so anyone in the future can try to download the data and make a system, score it, and compare, even try to improve. And I hope next year we will be here again with a new language, maybe a little bit tweaked this task. Okay, that's it. Thank you.
One question. Any question?
Could you just say again why you think the behavior on the YouTube data was different, the baseline compared to the participant system?
Because this data we provided, this Volino-SPAC ELSA, was kind of not read or dictated, kind of read or dictated data. Rather, the YouTube is a real presentation like I'm doing here now, so it's full of reverberation, noise, so it's a really different channel. And the baseline for the Open KWS, this system was trained on about 80 hours of Vietnamese data. with data augmentation, reverberation, so that system saw at least partly such kind of reverberated data. While for the participants, the participants can use evaluation data for unsupervised training for that.
If you want to use the flipper. Oh, okay.
It was quite difficult. It was really differential.
Then I'll have to copy these two.
So, just because there's we were at Institute Rush Interseach conference last